In this video, we're going to have a look at random variables and how they can be, analyzed in probability distributions. So probability distribution function is a function that allows us to determine the probabilities of all outcomes for a random variable. And that might be simply by giving a list of all the possible probabilities of all the outcomes. It might be an actual function. So some of the probability distributions that you may have encountered up to this point would be a normal distribution, which is an example of a continuous distribution, or a binomial probability distribution, which would be an example of a discrete probability distribution. So we're going to consider for today a hypothetical raffle that has the following probabilities. So you could win a cookie, which is valued at 75 cents, and that's a probability of 1/6, a a $50 gift card, or a $100 gift card, a television valued at $1,600, or a car valued at $35,000 with their associated probabilities. In this instance, X would be the value of the prize. So that's the random variable, and the probability is given. Now, it's important to note here, all these probabilities add up to about 17%. So the probability of winning zero, nothing, $0 value, so an X value of zero, would be about 83% to make up the remainder, because the sum of all the probabilities in any probability distribution has to be 1. There has to be a 100% probability that something will happen. So in this case, it's sort of taken for granted. It's not listed in the table, but the probability of winning no prize, which has a value of 0, and X value of 0, is going to be the remainder to make up that 100%. Now we can consider something called the expected value. So that's essentially an average. What's the average value of all the plays of this particular raffle, of all the entries? If you were to have multiple entries, for example, what would be the sort of average value of prize you would be expected to get? And the formula here is essentially saying I take the actual value multiplied by the probability of that value, and I sum all those up. So in this particular instance, that would be the 0.75 times 1/6, so I can just say divided by 6, plus the 50 divided by 500, plus the 100 divided by 2,000, plus the $1,600 prize divided by 10,000, plus the $35,000 prize divided by 1,000,000. And if we add all these up, we get an expected value of 47 cents, so 0.47. So that essentially means, if you look at it from the perspective of the person offering this raffle or the organization offering this particular draw, the cost of each entry is approximately 47 cents. So that's how something like Tim Hortons Roll Up the Rim, for example, that's how they kind of manage it. If they're saying, well, on each entry that we give, we're expecting to spend an average of 47 cents, they can factor that into their overall costs of offering the raffle. So if I were doing this as a fundraiser for something, I might be charging entries for this. I would make sure to charge something more than that. So if I charge $1 per entry, for example, I'm making some profit on that I can use as fundraiser or whatever. So that's the expected value. We also have this idea of variance. If you've studied normal distributions, you've seen variance. It's the square of the standard deviation. So with any probability distribution, the variance can be considered the expected value of the square of the differences between the individual values and the average value, which is essentially E of X, the average being the expected value here. We square them essentially as a means of not having to worry so much about the positive or negative of the situation. So is the difference between a given value and the average positive, or is it negative? We don't really care. We're looking for some idea of, on average, how far apart are these values from the average. That's a little bit of an oversimplification, but it does help to get at the heart of what it is we're talking about. That's the formula that helps us to understand a little better what variance is telling us. So it's the average of the squared difference between individual values and the mean. But the one that's usually easier to calculate is this second formula here, where we take the expected value of X squared minus the expected value of X, all squared. So this one is the 0.47 that we just calculated squared. E of X squared is if I take each x value and square it, so 0.75 squared, and multiply it by its probability, so in this case divided by 6, plus 50 squared divided by 500, plus 100 squared divided by the 2,000, plus 1,600 squared divided by 10,000, plus the 35,000 squared divided by 1,000,000. Now, notice in this, I'm leaving out the 0. I mean, technically, for both the expected value and this, I should be doing the 0 times 0.83 for the 83%. But because it's a 0, I can ignore it in the calculation. It's not going to change anything. So for my variance, I would add all of those up and then subtract the 0.47 squared. And in this instance, we end up with a variance of about 1491. That is also measured in dollars. So this is a pretty high variance, which makes sense if what variance is measuring is the spread of the values. Because if I think about it, I have the possibility of a number of prizes that are fairly low value. So very high probability of getting a 0, relatively high probability of 0.75 or 500 compared to possible prize value of $35,000. So it makes sense that we would have a pretty high variance in this case.